Hello everyone, this is Rishik from Rishik Math Tutorials. I'm back with another video after a long time. This time I'll be teaching how to complete square and solve quadratic equations using that method. So I personally enjoy completing the square and solving quadratic equations because I see it as a stepping stone between the two other methods that are taught in schools for solving quadratic equations. The factoring method, right, where you find two numbers that multiply to give you the constant and add up to give you the x term. That's more or less based on trial and error, and the quadratic formula, which is just formulaic, you memorize the formula. So I see completing the square as kind of the stepping point between the two. And it's really important that you understand how you complete the square because the quadratic formula is based on completing the square. It's derived from completing the square, and it's really important that you understand how to do so in order to fully be able to solve different kind of problems when you're trying to solve quadratic equations. So without further ado, let's get started. Let's try working through a problem, a relatively simple problem, where we will have to solve for x using the completing the square method. So let's just work through this together, and along the way we will learn together how to complete the square. So the whole concept behind completing the square is we want to make this left-hand side of our equation, we want to be able to rewrite it. Essentially, we want to be able to rewrite it as the square of a linear expression. Now, what does that mean? Well, we want to be able to rewrite x squared minus 10x plus 10 by adding some number to the entire expression or subtracting some number from it. We want to be able to rewrite it as x plus a number whole squared or x minus a number whole squared. And the reason being that by doing so, we will be able to rewrite our entire equation as two separate equations where we can take the square root of that squared of the linear expression, and we can get two linear equations, which will be very easy to solve. So yeah, it's just that transition to that linear square of the x plus a or x minus a whole square that we are really dealing with in completing the square. So the key point to understand when completing the square is that it's really difficult to add the x squared term or an x term to either side of the equation without further complicating matters. So what we tend to do is we tend to change the constant term, the term without any x next to it. We tend to change the constant term of the original equation in such a way that we obtain an equation that is representative of an x plus a whole squared or x minus a whole squared equation. So what does all this gibberish mean, Rishik? So what we're going to do is we're going to divide the coefficient of our x term, which is in this case negative 10. We're going to take a negative 10 and we're going to divide it by 2. And that gives us negative 5. And we're going to take a negative 5 now and we're going to square it. And we get 25. Now 25 is a special number in this case because if we can make 10, the original constant in our equation, into 25, then we will be able to rewrite this entire equation as x plus a or x plus some number whole squared. And that's the goal of completing the square. So let's do that without further ado. How do we get 10 to become 25? Well, we can add 15 to both sides, right? When I say change 10 into 25, I don't mean by magic. I mean what numbers can we add or subtract to the original constant to get a new constant? And in this case, it's 15. So we get x squared minus 10x, right? Because those guys didn't change. Same, we just drop them down here. Now we get this, 10 plus 15 is 25. And 0 plus 15 is 15. As usual, it's really important to remember if you add one value to one side of the equation, you have to add it to the other side of the equation as well to maintain the equality in the equation. So now on the left-hand side of our equation, we have this expression, x squared minus 10x plus 25, and you might see the structure of an x plus a whole squared or x minus a whole squared expression here, right? Because we have structured it in such a way that half of the middle term's coefficient, that's half of -10, -5, is the square root of our constant term, right? And that means we can rewrite it as a linear expression whole squared. So we can rewrite this as x minus, so minus minus, and the square root of 25 is 5, as we have just shown here. So this whole squared is equal to 15. And you probably see now what I was getting at with simplifying our equation with this concept of rewriting our entire expression as a square. Now we can easily, really easily, just take the square root of both sides. Nice rainbow color. So we can now take the square root of both sides, the square root and the square on the left-hand side cancel, right? And so we get x minus 5, the radicand, is equal to plus or minus the square root of 15. Now, obviously, we can't simplify the square root of 15 that much because 15 is just 3 times 5, and 3 and 5 themselves are prime numbers, so we can't simplify that much further. But we must always remember that when we take the square root of a number, we must always remember that there are two roots, right? There are always two square roots. There's always the plus and the negative. And that makes sense because when we're solving for the roots of a quadratic equation like we're doing now, a quadratic equation, since the degree is 2, we want two solutions. And those two solutions are going to come from the two roots here. So now if we add 5 to both sides, we just move 5, or we can add 5, whichever one works better for you. We now get x is equal to the plus or minus square root of 15 plus 5, which means, this now means we can do x is equal to the positive square root of 15 plus 5, and x is also equal to the negative square root of 15 plus 5. So these are our two solutions. That's pretty much it. These are our two solutions from completing the square. Oops. Yep, those are our two solutions from completing the square. And you probably understand the entire concept behind completing the square now. The entire concept is rewriting this thing on the left, x squared plus or minus 10x plus 10 or whatever you're given as your original equation, as an expression that can be rewritten as itself as a linear term whole squared, and then you can just simplify it by taking the square root of both sides and rewriting x as the square root, positive square root of something plus something, and a negative square root of something plus something. So that's how completing the square works. I hope you found this tutorial helpful. I will be making another tutorial where I will be doing a slightly more complicated or a slightly harder practice problem of completing the square. Those problems are typically problems where your a value or your coefficient of the x squared term is not 1. Here it was 1, right? This 1x squared minus 10x plus 10. However, you also will have to be able to do problems where a is not 1, so you might have to do where it's 3x squared minus 10x plus 10, or 13x squared minus 10x plus 10. Often you won't get two big numbers for a here, but there are certain problems where you'll have to be able to do where a is not equal to 1. So we'll be doing such a problem in a future video. I hope this video was helpful for you. Stay tuned for more videos from my channel. I'll be uploading them regularly now. Please subscribe, share, like, all that good stuff on YouTube. Thank you, and stay safe.